So today we are going to discuss how to solve a particular problem. I have chosen this topic for the two reasons. Some of the first year students, you are entering into project-centric learning, where you have to talk about problem solving. You have to identify a problem and you have to solve the problem in next 4 years time period. Am I audible? Any issue?
Yes, ma'am, you're
Yeah,
audible.
okay. That's one reason. And the second reason is if there are some final year students, they will be doing their project. And I believe this lesson will also be useful to them. Now, how to arrive at a research problem? How to identify a problem? This is the $1,000,000 question. Many students are finding it difficult to arrive at a research problem. Somebody is talking. Can I request all of you to mute? Can I request everybody to mute? Thank you. So, how to arrive at a research problem for which we need to acquire some evidence. The first step to identify a research problem or a project or a project-centric learning is to research the databases. Okay, what are the databases that we have which you should look at? You can, the simplest of all is a Google Scholar. You can go to Google Scholar, you just type in Google, you can type Google Scholar, and then you put some keywords on the topic on which you want to do research. The second option is you can go to some other databases like IEEE Explore. You can also go to ACM. You can also go to ProQuest. So these are other databases from where you can find some information. Assume you're just typing a keyword classification. Just your word classification in Google Scholar will give you 5,20,000 or even more papers will be listed. So more than 5 lakh papers will be listed. So you have to select the keywords in such a way that you get few number of records. Now, once you get all the records, it is not possible for you to download all the research papers and read them. So what you can do is you can exclude the records based on the title and based on the abstract. So just by looking at the title, you will know that whether it is relevant to your research or not. If you think the title is relevant to your research, then go to the abstract. Read the abstract. If you think the abstract is relevant to the problem which you are thinking that you want to work with, then you include that research paper in your... Hello? Right. So assume you are able to collect some 200 research papers based on the title and abstract evaluation. Once you get all those research papers, then you have to evaluate the full text. When you start reading the full text, I'm sure you will not get everything in your first attempt. You may have to read 2 to 3 times to understand the content. The most important part in the full text evaluation is the conclusion and also the future work, what is mentioned there. So Again, from the 200 papers which you have shortlisted, based on full text evaluation, you may arrive at around some 50 research papers or the 50 records. Once you get that, now you have to identify your problem. Create a summary of all the understanding from each paper, whatever you have obtained. And what is the gap that is mentioned in each of the paper? You will be able to definitely identify a problem to be solved. Now, once you identify the problem, you have to see whether it is original. When I say original, so that means nobody should have worked on the problem earlier. So that is original. See whether it is relevant in the present context. The problem should not be, 50-year-old problem. So for this purpose, while you're searching the databases, take the records which are, past 10 years only. See that the solution is feasible. See, your problem is specific and it is focused. When you have all these qualities, then you can understand that you have arrived at a problem to be solved. Now, once you have the problem in hand, what kind of problem it is? Now, look at this. What kind of problem it is? As far as computer science is concerned, these are the major types of problems. Most of your problem will fit into any one of this. It could be a classification problem. It could be a prediction problem. It should be grouping or clustering problem or an optimization problem. It could be an anomaly detection problem, some ranking problem, recommendation system, or some automation. So your problem will fit into any one of these categories. Now, let us look into each one of them. The first one is classification. When I say classification, it could be a binary classification or it could be multi-classification or multinomial. Multi-classification, we call it as multinomial. Let me give you an example of binary classification. You want to find out something is good or bad. So you have either yes or no answer, good or bad, either of the two. Assume you get an email. The system should detect whether it should go into the spam or whether it should go into inbox. Spam filtering. This is again binary. So when you have a problem, a classification problem, which is binary in nature, then you can look out for any of these algorithms like logistic regression, k-nearest neighbors, decision tree, support vector machine, naive-based algorithm. So these are some of the algorithms which are already existing. So if you look at any algorithms, good textbooks, you can find all this. All these algorithms are already available. Let me give you another example of a binary problem, binary classification problem. Take any medical image. Maybe it is a scan, maybe it is an X-ray. It could be any medical image. Now, you take medical imaging to find out the presence of a disease or whether the disease is present or not present. So it is again a binary. So in such, can you see my screen?
Yes, ma'am.
Okay. So I completed binary, multinomial, and I was going for prediction. So should I repeat it again?
Yes, ma'am.
Okay. Okay. So,
Yes, ma'am.
so this slide was okay, right? This was okay, right?
Yeah, ma'am.
Yeah. Okay. Okay, so now
Yes, ma'am.
one of the problem which we could solve is a classification problem. When I say classification, it can be classified into two: binary classification or multinomial or multi-classification. When I say binary classification, it is like yes or no. For example, you get an email, whether the email should be in your inbox or it should go to the spam folder. So the system detects that. So here it is the binary classification problem. You want to identify this is a good or bad. Again, it is a binary classification problem. Let's take for another example of medical imaging. So you could take X-ray, you could take scan. What is the purpose of taking medical images? So we would like to see whether the presence of a disease or it is not present. So it's again a binary classification. So the system detects whether a particular disease is present or not present. So in all these cases, it is a binary classification. So whenever you're having a problem, whenever you're having a problem of binary classification, then you have to resort to any of these algorithms like logistic regression, k nearest neighbors, decision tree, SVM, and naive Bayes. So these are some of the algorithms that are readily available for you to do the binary classification. Now, what is multinomial or multi-classification? For example, you have a flying object. The flying object could be an aeroplane, it could be a helicopter, it could be a kite, it could be a bird. So in such case, when you give an image, the system has to identify the particular object. So that is multinomial classification. All of us are aware of malwares, unwanted programs that are entering our systems. So you want to analyze the malwares, you want to classify them. This is again a multinomial or multi-classification problem. So in case if you want to address any of the multi-classification problem, you can resort to k nearest neighbor, decision tree, naive Bayes, or otherwise you can go for random forest or gradient boosting. So these are all these algorithms you can find in any good textbook. Now, getting into the next type of problem, which is prediction. What is prediction? From known to unknown. So you want to do some sales forecasting. What is the amount of sales I'm going to have next year? So it's a prediction. What is the value of a particular stock? Whether I should buy, whether I should sell. Stock market prediction. Who is going to be the next Nobel laureate? So how can I predict all these things? I will be able to do it based on the previous data. So I have some previous data in my hand, and then I can apply some modeling techniques, prediction modeling techniques. There are two kinds of techniques available for prediction. One is regression, one is neural network. So you can resort to any of the two prediction modeling techniques to find an unknown from the known data. Next is very interesting, which is clustering. Clustering, in other words, we call it as grouping. So when do we go for clustering? So whenever we want to find the similarity, then we go for clustering. And clustering is a very complex concept. There are different types of different techniques which are being used, like centroid-based, density-based, distribution-based, hierarchical-based. So there are different techniques available to solve a clustering problem. Okay, let me give you an example of a clustering problem. You want to do some pattern recognition task. You want to analyze the social network, the pattern that is available in the social network. You want to do some market research. So in all these cases, you can resort to clustering problem. So when I say clustering, so you have a lot of clustering algorithms that are available. So if you use k-means clustering, that is based on centroid. So when I say centroid, it takes the cluster in the form of a circle. You have density based. So if it is density based, then you can go for DB scan. Distribution based, hierarchical. So you can use any of these or a combination of these clustering algorithms. So what people do is, these days, whenever you have a clustering problem, you want to do some market research, then what you can do is, you can take the problem, you can take the data, then you apply all the methods, k-means clustering, DB scan, Gaussian mixture, Birch. So you can apply all these techniques, find out what is the result you are getting, then compare the result, and then whichever is best, you can go in for. The other alternative could be, you can apply 2 or 3 clustering techniques together also. Or another option is, you can take the existing algorithm, you make modification in the existing algorithm, create a new algorithm for clustering. So these are some of the options you have for solving the clustering problem. Next is optimization. If you look at many of the PhD theses, most of them will talk about optimization. When I say optimization, which means finding the best solution from all possible solutions. Finding the best solution from all possible solutions. One example is maximizing the profit. Another example could be to minimize the cost of production. These are the major business problems which we have for the optimization. So there is always a trade-off. Time, cost, profit. So there is a trade-off. You have to work on it. So there are this optimization methods. If you look at on the right-hand side, I have given you a picture which states that there are different kinds of optimization, different types of optimization methods that are available. Now, if you go to Google Scholar and you search optimization, assume you're getting an example, you're getting a paper with a genetic algorithmic approach to optimize a particular optimization method. Okay. Now the question is, just now, okay, last 1 minute only, okay. I think some network issues there.
Host.
1 minute. Can you hear me?
Yes, ma'am.
My screen is visible?
Yes, ma'am.
Okay. So we were talking about the optimization techniques. So depending upon the problem in hand, you need to decide what kind of algorithm you need to choose. Whether it is linear or non-linear, whether it is exact or approximate, whether it is heuristic or random search, whether it is evolutionary, whether it is simulated or anything. So depending upon, the problem you're having, you have to choose a particular algorithm. Can you all see my screen?
Yes, ma'am.
Okay. Next, we have anomaly detection. Okay. What is anomaly detection? Fixing before things go wrong by finding the anomalies. Let me give you an example. There was a recent attack in Ames. How many of you are aware of that? So there was a recent attack in Ames database. Now, they did not find the anomalies. That is the problem. So the attack was not done on a single day. So it was done in bits and pieces. And if they could have identified the intrusion, or if there was a mechanism to detect the intrusion, then the particular attack would not have happened. So intrusion detection, fraud detection, all these are examples for anomaly detection. So when I say anomaly detection techniques, there are different techniques available: statistical, spectral, information theoretic, machine learning, streaming. The same problem of intrusion detection or anomaly detection can be identified through all of these techniques. Now, how will you go about when you want to do some intrusion detection? You can resort to statistical method, a very simple method, or you can consider it as a classification problem, or you can consider it as a clustering problem. So the definition of the problem determines what kind of technique which you're going to use to solve the particular problem. So if you assume that you want to resort to machine learning, so either you can opt for classification or nearest neighbor or clustering for the same problem of anomaly detection. And now we assume you're resorting to classification. If you're going for classification, there are 4 different methods available. You can go for neural networks, you can go for SVM, you can go for rule-based, you can go for Bayesian. Now you can classify whether there is anomaly or not by applying all these techniques. Or a combination of these algorithms will work, or otherwise you can also modify the algorithm such that you create a new algorithm to detect the intrusion. So this is how an anomaly detection problem could be done using a machine learning. It can also be done using histograms, which is a non-parametric approach, or you can also go for a Gaussian or a regression method, which is a parametric approach. So depending upon what kind of technique which you want to use, you can define the problem. Next, we go in for ranking. I hope all of you are aware of ranking. When I say ranking, this is to establish some type of priority. Let's say, for example, we have NIRF ranking. We have, NIRF ranking ranks the universities. We also rank the students in the class based on your performance in the test. Some type of priority. So that we call it as ranking. When I say ranking, there are 2 ways of doing it. One is deterministic ranking algorithm or a probabilistic ranking algorithm. Assume in a classroom there are 100 students. I'm giving a test to all of you. I want to rank the students. A simple sorting technique is enough, which is a deterministic ranking algorithm. A simple sorting. There are different sorting algorithms. I think you must have already studied or you're going to learn. There are different sorting techniques. Bubble sort, merge sort, quick sort, so many sorting algorithms. So you can resort to any of the sorting algorithm to determine the ranking. Now you look at Google, Facebook, Amazon, Twitter. So all of these algorithms, all of these pages, they also use ranking, but we don't know what is the algorithm actually they are using. But they use what is called as probabilistic ranking algorithm. They use probabilistic ranking, that is a technique. They use probabilistic ranking algorithm, but the exact steps or the algorithms, it is kept always as a secret. So you can also create a ranking algorithm. So let's take, for example, Google. So how it determines which page should be given on the top. So you have a Google page rank algorithm. So similarly, Amazon, when you search for a product, which product should be on the top? So it is decided by an algorithm. So all of these companies, they use what is called as probabilistic ranking algorithm, which is based on Bayesian. So if you want to create your own search engines, your own ranking algorithms, you can use probabilistic ranking algorithm, create your new algorithm for this purpose. The next one is a recommendation. I search for something in Google. Now, when I go to Amazon, when I go to YouTube, there is an information retrieval or the information filtering system. The information filtering system is in place. Example is your YouTube. Assume I'm listening to a song from a particular singer. So it automatically filters and gives me recommendations. So these are your, it understands what I want. So the recommendation systems, let's take another example also. Netflix. Netflix is using what is called as collaborative filtering. So again, this information filtering system, we can classify them into first generation, second generation, and third generation information filtering system. When I say first generation, knowledge-based, content, collaborative filtering, hybrid, all these are first generation filtering system, information filtering system. Netflix comes under collaborative filtering. When I say collaborative filtering, it is based on the user, it is based on the items. So user or item collaborative filtering. So when I say knowledge based, it is, or the content based, it is based on some kind of keywords. Then we have second generation and third generation also being used along with the artificial intelligence. So we use nowadays collaborative filtering using deep learning techniques. Similarly, content based, now we call it as deep content based learning. Also, we have what is called as the CONN represents convolutional neural network. So we are combining the models of users and items. So earlier it was user or item. Now we are combining the modeling of users and items using reviews. You're all able to see my screen?
Yes, ma'am.
Okay. So these again, so when you want to resolve a problem, you want to develop a recommendation engine, so you can do it using any of these techniques. I suggest that go in for a third generation, so where you use deep learning as well as convolutional neural network. So these are some of the new advancements in the field. Now the last one is creative automation. Okay. So what is creative automation? Now, can you imagine your computer to write a poem for you? Can you imagine a computer to compose a music for you depending upon the inputs, some inputs which you give, some of your preferences? So this, we call it as creative automation. Similarly, these days, people are using creative automation for running high volume advertising campaigns. So this is creative automation. This is something very new where you can put in your work, how to create, how to make the system think like you. So I'm sure you know how to write a poem. I know how to, some of you may know how to compose a music. Some of you know how to play chess. How can you make the system to think like what you're thinking? So that is creative automation. So I'm not talking about industrial automation here. I'm talking about creative automation. So can you ask your computer to write a novel for you? So if you could do that, that is something great. And you can, of course, be very creative to create such kind of algorithms. These are some of the hot topics which you can think of for solving the problem. Next. Now, coming back to my first, I said, so first I told you how to arrive at a research problem. I talked about how to find the gap. I talked about when you have a problem in hand, how it could be solved. So you can categorize your problem into any of these. Either it could be classification, prediction, clustering, optimization, anomaly detection, ranking, recommendation, or automation. So when I say automation, it is creative automation. So you can identify a problem and the problem could be classified into any one of these categories. Now, you know, for each of these, there are certain algorithms available, certain procedures available. Now, you can take those algorithms and you can apply it on your data. Initially, for if you're a first year student, I'm not asking you to create your own algorithm. So take the algorithm as such, put the data and see how it works. Now, if you are using an existing algorithm, you can do a comparison. So that's what I want you to do. This is the last step. Evaluate your solution. So when I say evaluate your solution, so it is not just implementation of the algorithm. So the algorithm is already existing, you can implement it, or you can modify the algorithm and you can create a new algorithm, or completely from the scratch, you can create a new algorithm. Now, it is not only that you're implementing your program, but you need to also evaluate. So when I say evaluate, so you have to give data. So you have to provide data and then you get the result. Once you get the result, now the next step is comparing your results. How will you compare your results? Somebody would have already experimented that. Somebody might have got the result. So compare what is the result you are getting with that result. If the results are not promising, then you have to find an alternative solutions. Right? So this part we call it as validation. So first one is identification of the problem. Once you identify the problem, then what is the methodology you are going to use? So we discussed in detail the different methodologies, each problem, how it could be solved. After implementation, you need to validate. The validation can be done by giving some test data, providing some data. For example, you want to find out a person is suffering from skin cancer or not. So what should you do? You have to give the data to your system. Some data, which is some people who are having skin cancer, images you have to give. Some images which who are not having skin cancer, you need to provide. So then you will run the program several times. You will be testing, you will train, you will test. And then once you get the result, you have to compare the result. What is the accuracy? What is the complexity? So you need to compare your results with the existing research paper that are already available. And if the results are good, then you have achieved something. Otherwise, you have to go back and redo whatever you have done. So with this, I complete my session. If you have any questions, we can take up.
Thank you, ma'am.
Okay, so
Thanks, ma'am.
okay, so now I have a question assignment for you all.
Assignment is there. Okay.
Okay,
Ma'am.
okay. Now you can go to Google Scholar. Okay. All of you have gone to Google Scholar?
Yes, ma'am.
Okay. Now you type classification. You can type anything, classification, anomaly detection, clustering. You can type anything in Google Scholar. Right? So on the left-hand side, you can find year-wise. Any time is there. Since 2022, since 2021, since 2018. On the left-hand side, you can see that.
Yes, ma'am.
Yes, ma'am.
Yeah. So now, assume you want to see what is the research that is going on in classification since 2018. So we just want to see only some 4 or 5 year data. Okay, click on 2018. Okay, earlier it was 52 lakh research, now it is 12 lakh 90,000. Okay, in 5 years, this many papers. Okay, now in classification, what do you want to do? Assume you want to do text classification or feature classification, or you want to find out how many people have used support vector machine in classification. You can search based on that. Okay, I'm going to see convolutional neural network classification, CNN. When I say convolutional neural network classification, I'm getting now only 7,69,000. Okay, so likewise, you have to search and then you have to select few papers from this. Like for example, I want to use convolutional neural network classification for medical imaging. Assume I'm doing medical imaging. Okay, so you can take up any problem. Now it is only 2,37,000 result. So likewise, when you keep on adding more keywords, so the number of papers also gets reduced. Now, once you have sufficient number, you just look at, the papers which are relevant to your research. And you start reading the abstract. When you read the abstract, then you will understand whether it is relevant to your research or not. So my assignment to you is, I want all of you to come up with one problem identified. Can you do that? Can you identify one problem?
Yes, ma'am.
Okay, so I'm not asking you to implement anything. I'm just asking you to do Google Scholar search. I'm not asking you to go for any other search also, no other database, only Google Scholar search you do. Different keywords you use, okay, and you arrive at your problem. Okay, I just gave you an example of a classification problem. You can take any cybersecurity problem also. Okay, you can take fraud detection. You can just put a keyword fraud detection. You can say spam filtering. Okay, so you can give some keywords and take few papers and start reading the abstract. And based on the abstract, you will understand whether you have to go in for full paper download and then whether you want to read a full paper or not. So once you start reading the full paper, initially you may not understand anything. Okay, so read several times and then identify a problem. Once you identify the problem, then come to me. We will have a discussion. Any questions on this? Any questions? Okay, so I will be sharing this presentation with all of you. Okay, so the first slide only we are going to do now. So the first slide, which I discussed, evidence acquisition, where you will try to find out the problem. So that will be your assignment. Understand? If you have any questions, let me take.
No questions, ma'am.
Okay, thank you all.